feel like, oh my gosh, I'm gonna miss these learning targets and never learn them. Okay, so here's where we're at. Yesterday we talked about graphing in standard form, right? So in standard form, that's when you're given it to, some people will call it factoring form. So standard form is when you have y equals x squared plus 6x plus 5, right? And that's when you had to go through and do the opposite of b over 2a. You had to find the vertex. You had to plug things in. And it was kind of a big process, right? Okay? That was the last learning target that we took, quiz that we took. And man, it just wasn't fun. There was a lot of steps, okay? And the more steps, the more opportunity for little errors, right, along the way. So I'm going to show you an easier way to graph today, and that's vertex form. All right, so first, you kind of already know what vertex form is because we worked with it all day yesterday when we were playing on the calculators, except I didn't really come out and tell you what it was. So this is where I want you to just write right now, just in your regular color ink now, not one of your colors yet. So y equals x squared, we called it our parent function. And in our parent function, we know the vertex. The vertex is 0, 0. Our axis of symmetry is just x equals 0, right? It's really just the y-axis. Not much special going on with this. No changes in shape or reflections or horizontal. It's all pretty boring, right? Okay? So then in the same color, I want you to kind of watch what I'm about to do. So I want you to write y equals, leave a little bit of a space, put your x minus, and put a squared and leave a space. So y equals, leave a, when you're in kindergarten and you first learn to write a space or indent, they make you put your finger there. So leave a space, put your x, then and a minus, and then leave a space, and then go from there. Because we're going to kind of build this form ourselves. So I'm going to take my purple, and I'm going to put a purple A. Then I'm going to take my red and put a red H. Then I'm going to take my green and put a green plus K. And these are 3 of the 4 things that we already learned yesterday. We ran out of time to be able to kind of sum up what we did. So if we had 70-minute class periods like the high school does, then this would have been great. We would have done this right after that calculator activity yesterday. So I want you to point to the purple A in purple. And what does the number, the coefficient, in front of your x term control? What did we learn yesterday? It controls the width, right? Yeah. So let's just put the word width. Okay. And 2 things can happen with your width. You could either have what we called a stretch or a compression. My marker is too fat to write with. Okay, so you can have either a stretch or a compression. Okay. So when do we have a stretch? Remember, this is one of those ones that did the opposite. Stretching it out means it's getting bigger, which makes you think the number's bigger, but it's really, okay? So A is less than 1, but we got to also put something else in there, another restraint or constraint, because -5 is less than 1, but that's not a stretch because 5. So it also has to be greater than 0, right? And to put that, do you remember when we did double inequalities? So basically what that is saying is just that, okay, make sure the width of A is between, because A is physically between 0 and 1. Okay, so the negative is totally separate. All right? You have a compression, meaning I'm taking that and pushing it together and making it real narrow and smaller, but the number is bigger. So when A is greater than 1, that's when you have a compression. Go ahead and take a different color right here. And when do you have neither? When A equals 1. When A is 1, meaning there's nothing in front of it. then that's called no change. No stretch, no compression. It is your standard width of your standard parabola. Do you understand what A controls? I think you do because you showed me yesterday. So let's move on to H. There's always reasons why they choose variables. Like, remember M for slope? People are like, why did they choose M? And I don't know if I told you, but M is a Latin or a French word for monter, M-O-N-T-E-R, and that means to climb. So slope, climb. Okay, so I don't really know the exact definition or reason. I'm sure there's some Latin word that starts with H, but I kind of like it because that controls your... No, oh gosh, don't say that. Don't say height. I never thought of it. That controls your horizontal, which is the exact opposite of what I wanted you to say. Right? It controls your horizontal. Okay? So get that height word out of your head. I never even imagined that. So this controls your horizontal. Okay? I'm going to give you something better to help you with the height. So horizontal shift, and it could either go left or it can go right. And when does it go left? And when does it go right? Thinking of the concept of finding the zeros. It goes to the left when there is a plus. So these first two do the opposite of what you think they're going to do, right? And it goes to the right when it's a minus. Okay, which then leaves us with the K. And the K, this I know is totally made up because it doesn't even make sense. Think about a kite. I don't know if we talked about this yesterday, but where do kites go? They go up in the air and then they come down, right? If you don't have a good one. So K controls the vertical shift. Okay, so when does it go up and when does it go down? It goes up. This one is true to what it says, right? It goes up when there's a plus at the end, and it goes down when there's a minus at the end, right there in that spot, okay? And then the last thing I'll have you do, just kind of put in, it doesn't matter really what color. That, like, if I ask you, if you were ever on, like, the Who Wants to Be a Millionaire, and they say, for the $1 million question, what is vertex form? You have to be able to say it. It's y equals a times x minus h squared plus k. All right? Like, remember when I told you about point salt form? y2 minus y1 equals m times x minus x1, and you were like, what in the heck is that? Like, you never thought you would remember it, right? You need to kind of just know what vertex form is. It's the a times the quantity, or the difference really, x minus h squared plus k. So kind of start to get that in your head there a little bit, okay? What is not part of vertex form is this minus. So I guess I should add something in over here about a. If a is negative, that controls the fourth transformation, and that's the reflection, right? So if a equals negative, there will be a reflection. But in your regular vertex form, they won't put negative a. They'll just put a. Okay, so what you are about to see, First Hour thought it was pretty cool. They were like, oh my gosh, this is so much easier. So they don't call it vertex form for nothing, right? Why do you think they call it vertex form? Because with your eyeballs just looking at it, you can tell me the vertex in a matter of a second. That's why they call it vertex form. For example, y equals 3 times x minus 1 squared plus 5. You didn't really realize it, but when you were filling out all this stuff yesterday and telling me where to shift, you were telling me the vertex. If you told me to shift 1 to the right and 5 up, There's your vertex. Your vertex is 1 to the right, which is 1, and 5 up, which is 5. Holy cow. Would you, unless you'd rather do the opposite of B over 2A, plug that in and do all that other stuff. Okay, do you see what I'm saying here? And kind of, in a way, when it was given in standard form, like this, I kind of had no choice. I had to do that craziness to find the vertex. But when it's in vertex form, it's like a big party. Woohoo! In a matter of seconds, I know the vertex. So think about what that means. That means that you know at 1, 5, there's your vertex. And all you're missing is those 2 other points. And you know how to find those. But here's the other thing to think about. If you know your vertex, you also know what? Your vertex is always on your line of symmetry, axis of symmetry, right? So if you know the vertex, we're going to talk about what to do to find our point. We're getting ahead of ourselves. So our line of symmetry, or axis of symmetry, is 1. Okay, let's do this. Y equals 1/2 times x plus 7 squared minus 3. Quick, tell me the vertex. I know you're still writing it, but 7 to the left, 3 down. There's your vertex. -7, +3. So it's kind of weird because it does the opposite of the parentheses of what you think, but you're really looking at a -3, and that's down 3. Okay? This one more. Y equals x plus 2 squared minus 1. Ben?
Would that be -3?
Yes, thank you. Sorry. Yep. Talking too fast. Well, because it's a -7 because you're shifting 7 to the left. And thank you, Ben, for catching that. So -3 and the down 3. Okay? So now what would that be? Right, just when you think you got it, I went and switched it up on you, and you're probably like, what? So what would this be? 2 to the left, 1 down. Got it? Okay. Now, there's always those annoying special cases where something's off, right? So let's talk about when something's missing. Okay? So let's just look at this. Y equals 2 times x minus 4 squared. And when not all the pieces of the form are there, you know what I tell you to do? Then put them there. You don't see anything after that x squared, so put a 0. So now that makes it easier for you to find your vertex. What is your vertex? You went 4 to the right and none up or down. This is sitting on the x-axis, right? And what is your axis of symmetry? Whatever your x value is, right? So that's when there is no vertical shift. Let's take a look at this one. This one's a little weirder. Y equals x, let's say 1/2 x squared minus 2. Okay? There's no parentheses. Okay? Here's a huge hint. If there are no parentheses, what is in the parentheses? The horizontal shift. So if there's no parentheses, there's no horizontal shift, meaning it's somewhere on the y-axis. But some people have a hard time seeing that. So you know what I tell them to do? Put that. Okay? So looking at that, you see, oh, the horizontal shift, there isn't one. So my vertex is going to be 0, comma, -2, which means it's right on the axis. And then from there, I'd have to look, does it reflect? Does it compress or stretch? But right now, I know that my axis of symmetry is pretty much the y-axis. Okay? So this is if there's no vertical. This one is if there's no horizontal. And you may not know it or not, but you already know what it's like when there's none of either. It's the parent function, basically, right? So y equals 2x squared and nothing else. Or let's say negative 2x squared. This is really what this looks like. So when you are looking at your vertex form and you think you're missing something, if you can't quite figure out which one's missing, then write a whole vertex form out. Put a 0 where there's nothing. So now you know the vertex is 0, 0. Your axis of symmetry is x equals 0, which is basically the y-axis. So then how is this different from the parent function then? Because it's reflected and a little compressed. Got it? Is this starting to sink in? Okay? Very good. So now, the only thing we have left to do is to get this on the graph. Right? So, now, let's finally put all that together and graph it. Woo, careful. That's okay. At least it's not a fancy one, right? So, if I were to, let's take these. Let's take these ones. You already have these ones written. Okay? So, let's take y equals the opposite of x plus 5 squared minus 1. And I don't need you to tell me where does it go, what does it do. Just do it, right? Actually, don't tell me it, do it. Put the points on the graph and sketch it for me. So, if this was standard form, I would have to do all that stupid process and find the opposite of this. But I'm looking at my starting point. It's what? Negative 5, negative 1. Awesome. I'm already a ton ahead of where I was in standard form. Okay? So if I know my vertex, what else do I know? Yes. You may not think you need that, but just keep it there for a minute. All right. Well, what am I missing? You need 3 points to make a parabola. I only have 1. Where can I get my hands on another point? And if you have short-term memory loss, we did this 24 hours ago, right? You just pick a point and plug it in, just like we did. So the step 2, whether it's standard form or vertex form, step 2 is the same. It was finding the vertex that was a pain in the butt, right? But with vertex form, it's there. So now, if this is negative 5, this is negative 4, and this is negative 6, remember what I said? Don't go crazy. Pick one of those two, and always pick the smaller one. And if one of them's positive, pick a positive one. So I'm going to take negative 4 and do what with it? Substitute it in for x. But before I do that, we get a little caught up sometimes with what we're doing, and then we might forget what we're doing. I'm looking for a point when x is negative 4, so let's do it. Y is equal to, x is not x anymore, it's 4. So 4, negative 4, plus 5 squared minus 1. And this is like, once you get to this point, you should like breathe a sigh of relief, because this is just a little old itty bitty baby order of operations problem. That's all it is. Do the parentheses first, then do the exponents, then multiply and then add. So let's do the parentheses first. And your best bet is to show everything. Okay? So a lot of you, this negative right here really screwed some of you up on that last check for understanding, because right now it's outside the parentheses. I'm not asking you to take negative 1 and square it. I'm asking you to take 1 and square it, and then give me the opposite of it. Do you see the difference? That happened to a couple of you. So, what is 1 squared? 1. And now what's the opposite of it? Negative 1. And what's negative 1 plus another negative 1? Negative 2. So, I have my point already sitting up here. I am almost home free. I have to, and then here's where here's where you breathe a sigh of relief. When you go to put your point in, negative 4, negative 2, ooh, does it open downwards? Because it sure does look like it. And then you look up here and you go, whew, right? Because if it opens down, but your point ends up somewhere up here, Something's off, right? And here's where your axis of symmetry comes in awfully handy. Because if it's 1 to the right over here, then it's 1 to the left over here. You have your 3 points. There's your parabola. It even looks a little skinnier. Or actually, not this one. It's the next one we're going to do. Okay? We're going to do one more and then we're done. You with me? Okay? All right, one more. And then graphing in vertex form is way easier, isn't it? Okay? Great. So let's graph y equals, this is number 2 from your homework from yesterday. -2 times x minus 4 squared plus 3. So identify the vertex. Identify the axis of symmetry. Give me one more point. That's all you need. So what is the vertex? You're looking at it. 4 to the right and 3 up. Okay? Your axis of symmetry is whatever your x is. So before I pick my point, I might kind of want to, and I'm going to give you graph paper. You're not going to have to sketch it. So I'm going to 1, 2, 3, 4, 1, 2, 3. That's right there, which then my axis of symmetry is a vertical line right through that. If this is 4, then this is 3, and this is 5. Which one would you pick? I mean, you could do 5 if you want, but I'm going to pick 3. Okay? So is it becoming a little more clear which point to pick? I know that we were kind of confused on that at first. So now all I have to do is do this big O problem with x is 3. The ultimate order of operations problem. Parentheses, exponents, multiplication, addition. You are hitting every level, aren't you? So we are looking to find out what y is going to equal when we made x 3. 3 plus -4 is -1. You want to get yourself in trouble? Skip steps, right? That's the way to get yourself in trouble with order of operations. It takes a couple extra seconds. What's -1 squared? Now this time it's -1 squared, right? That's +1. And what's -2 times +1? I mean, that step right there you probably could have done in your head, but I'm just showing you every step in case you want to show it. So all of that work later, when x is 3, y turned out to be 1. Now I just better hope it lines up and it makes it open the direction I need it to, which is down. 3, 1 looks awesome. And you know what makes it even more confident? Because it looks a little kind of skinny, doesn't it? Right? And how do I know that it's narrower? Because of that, too. Is this all coming together for you? Yes? Okay, good. Because